Welcome to final BSc Statistics students. In paper 6 in unit 1, today we discuss lesson 6, uses and interpretation of control charts. Uses and interpretation of control charts. First of all, uses of control charts. Control charts are used to detect the assignable causes of variation in any production process. Very first important use is to detect the assignable causes of variation. What are assignable causes of variation? Mission setting, adjustment of mission, negligence of the part of the operator, which means improperly handling the missions by operators, etc. To identify the assignable causes of variation, we are using control charts. Control charts are used to determine whether the given process is meeting the specifications in any production process, which are used to determine whether the given process is meeting the specifications. Whatever the specifications laid down by the company, by the producer, control charts are used to determine whether the given process is meeting the specifications. What are the specifications? Something like measurements. They will specify some measurements. For example, a car manufacturing company produces cars. The measurement is nothing but specific. They will specify this much mileage is required, etc. So an electrical fan, to produce electrical fans, the company specifies the lifespan of the electrical fan should be this 2000 hours, 3000 hours, etc. Like, which are specifications. What you have to test? We have to test whether those items, the items produced by the company, which are meeting the specifications in any particular production process. That is another important use. The control charts for variables are used if the qualitative characteristics of the product are measurable in specific unit. Just now I explained. Control charts for variables, which means XBar, R and S charts. Usually these control charts are used if the qualitative characteristics of the product are measurable in specific units. Whatever the quality, lifespan of the electrical bulb, of the electrical fan, etc. It can be specified. Why? It can be specified in a particular hours. This much of hours, 2000 hours or 3000 hours, that the lifespan of the electrical bulb is. So therefore, whichever qualitative characteristic of the product which are measurable in specified units, then we can use control charts for variables. In such a situation, we can use control charts for variables XBar, R and S charts. Fine. Similarly, now control charts for attributes, P, NP and C charts, which are used if the qualitative characteristics are not able to measure quantitatively. Whenever a particular qualitative characteristic which are not measured quantitatively but can be identified with presence or absence of the product. If we want to specify the quality, what is the quality of the item? That cannot be identified, that cannot be measured. Therefore, for which we can specify only, that is, which can be identified with the help of presence or absence, which means usually in any kind of situation of industry, Usually in industries or companies, usually only measures whether the item is defective or non-defective. Defective or non-defective. So such kind of situations. In such a case, control charts for attributes are going to be used. Next, the study of identifying assignable causes of variation further leads to rectification or changing the production procedures. It is very important study of identifying the assignable causes. After studying the assignable cause of variation, it leads to rectification or changing the production procedures. Rectification means how can we modify or we can rectify our mistakes so that we can improve our procedures. Similarly, any changes are required in any kind of production procedures. It is also very, very important. What changes are to be made? What kind of changes are to be made in the production procedures? That can be identified in studying with the help of the assignable causes. After identifying the assignable causes of variation, by studying whatever the assignable causes of variations are present in the procedure. Next one. Control charts are used to separate good products, that is non-defective good products, from the bad products, defective products. The control charts are used to separate good products from the bad products, that is non-defective items from the defective items, which are going to be replaced. Only the simple reason is we definitely replace in any production process whatsoever a defective item found, which are to be replaced with good ones. The lot should not consist of whatever inspected defective units which should be replaced, and then only lot is going to be prepared. Lot should be free from the defective units. Come to the next one. The control charts are most useful for reducing the inspection cost in the production process. Control charts are most useful for reducing the inspection cost because of your inspecting less number of items. Okay. The control charts are the best techniques to streamline the workers and personnel in the industry by specifying the proper reasons for the variations in the production procedures at a minimum cost. You leave the minimum cost, we see later. But you see, we can streamline the workers because by giving proper indications to workers and personnel, these are the points are to be checked, which are going to be checked. These are some of the important points which are going to be identified and which are to be eliminated. These are the indications which we have drawn from the assignable cause of variation. By identifying the assignable cause of variation, if you explain, definitely we can streamline. If you give warnings at regular intervals of time, whenever it observes some kind of indications, if you are giving to the workers by supervising, etc., is by using the best supervision and giving the rules and regulations and specifying the whatsoever the reasons studied regularly to the workers and personnel, definitely which they will be streamlined. They are streamlined. So these techniques are best techniques. The control charts are best techniques because at regular intervals of time we are doing this particular procedure. We are applying statistical quality control and we are constructing the control charts, which gives what kind of assignable causes are present in the process. If you specify to the workers regularly, those the personnel who are working in the industry, we can specify some clear reasons by indicating this and that. Definitely workers will be streamlined, all personals will be streamlined. And by, you see the continuation of the point in the industry, by specifying the proper reasons for variations, what are the kinds of variations we can observe in the production procedures at a minimum cost. It is obviously no need to discuss a minimum cost, because of we are doing inspection for less number of items, only a part of items in the lot, some items in the lot. And these are, that is, control charts are useful tools for indicating when to adjust and when to leave the process. That is, this is the one of the important point we have discussed in uses of SQC as well, statistical quality control. This is one of the control chart it indicates when to adjust the process, when to leave the process, what is the time exactly it is going to be leave, and on which particular time it is going to be leave the process and adjust the process. These are the two important points in any kind of industry. In any industry, in any company, it's very important when to adjust the process, when to leave the process. That means if you consider a mission and manpower, etc., whatever it is, when to adjust, when to leave the process, right? Now come and enter into the interpretation of control charts. If all the sample points fall within the control limits, that is between UCL and LCL, then the process is said to be under statistically quality control. That is the first interpretation. This is very well known interpretation. Second one as well. If at least one sample point fall outside the control limits, either above UCL or below LCL, then the process is said to be out of statistically quality control. The first point is the process is under statistical control. The second point is regarding to the process is out of statistical quality control. If all sample points fall within the UCL and LCL, then the process is said to be under statistical quality control. If at least one of the sample point fall outside the control limits, then the process is said to be out of statistical quality control. See the third point. The most commonly used control charts for variables, that is XBar chart. Usually we use XBar chart is the most commonly used control charts for variable, which indicates the variation in the averages of samples. That is, it shows the catering of the process. What is meant by catering now? You see, we are calculating means for different samples. For example, 10 samples we have considered, out of which we have to calculate sample mean for all 10 samples, sample mean for first sample, second sample mean, third sample mean, etc. We have to calculate for 10 samples. And then whenever the process is out of statistically quality control, then it indicates catering of the process, which means sample 1, mean of the sample 1 differs largely mean of the sample 10 or 8 or 9, etc., with the remaining other samples which are much scattered. So therefore this is one such indication of considering what kind of variations we can observe between the means of the samples. That is very important. So we see in the next point, if the process is out of quality control according to XBar chart, then it reveals mission setting is one of the main assignable cause of variation present in the process. So while observing with catering of the process, if you observe that according to XBar chart, the process is out of control, then we can specify it caters. The process is going to be catered according to mean. It is not a variation is observed through the variance or standard deviation. It is observed through the process of means, calculating the means, identifying the means. From one sample mean to another sample mean, it caters. It disperses according to the means. The means are not observed which are not closely to the process mean. Still to specify very clearly, if I specify process mean, if the process mean is 40, that is we have to prepare with the average 40. Some kind of, for example, you consider mileage of a car. But one is giving, one sample is representing 25, another sample is representing 45 or 50. So which means it is catering. It is called nothing but it is the indication that it shows catering of the process. So therefore, if you consider there is some kind of changes are there in the mission setting, that is one of the important assignable causes of variation according to XBar chart we can specify. That is called catering of the process. Based on this, we are giving a particular conclusion that mission setting is one of the assignable causes of variation. You remember, XBar chart means it indicates if the process is out of quality control according to XBar chart, then it reveals mission setting. You remember, XBar chart gives one of the assignable causes of variation. If the quality is out of quality control, then the mission setting is one of the main assignable cause of variation. Then come to the R chart. The first point is R chart shows variation in the ranges of the samples. It indicates uniformity. That indicates catering, XBar chart. This indicates uniformity or consistency of the production process, which means R chart reveals the important assignable cause of variation, which is negligency of the part of the operator. You see, inconsistent, it is not consistent. If it is out of statistical quality control, according to R chart, if any particular control chart, any particular process specifies out of statistically quality control, which means it is inconsistent. R chart indicates consistency, uniformity, if it is under statistical quality control. If it not under statistical quality control, then it indicates inconsistency, non-uniformity, no uniformity and is there in the process. Certain process, whatever we have measured. And inconsistent. Inconsistent means what is the assignable cause of variation? Negligency of the part of the operator. Negligency on the part of the operator. So operators are not performing well. They are neglecting some kind of rules which are framed to use that mission or operate that particular kind of procedure. Operate to a particular procedure, they are not doing properly. That is called negligency on the part of the operator. These are the usual general interpretations. Now come to the special interpretations. Seventh one, even all the sample points are within control limits. See, this is why I specified special points, special interpretations. Even all the sample points are within the control limits. But a run of 7 or more points above or below the central line. What is meant by run? Run means continuous 7 points, 7 or more points, continuously. We have considered 20 samples. For example, from 3rd sample to 10th sample or 11th sample, continuously all the points are below the CL, or below the above or below the CL, but is in between CL to LCL or in between CL to UCL. It should not happen. It should not happen. That is continuously 7 or more points below the CL or above the CL. But whereas if you consider all the points are under control or within the UCL and LCL, but you observe the thing clearly, run or 7 or more points, continuously 7 or more points fall above CL or below CL, that is between CL to UCL or CL to LCL, between CL to LCL. Then in such a case, according to R chart, a run of 7 or more points above the central line indicates variability in the process has been increased. A run below the central line indicates variability has been reduced. According to XBar chart, it indicates shift in the process, not processor, shift in the process. If a run of 7 or more points fall above CL or below CL, according to XBar chart, it indicates shift in the process. Process has to be shifted. The procedures has to be shifted. Procedures have to be shifted. According to our chart, a run of 7 or more points above the central line indicates process has been increased. The variability in the process has been increased. Whereas run below to the central line indicates variability has been reduced. According to XBar chart, either above CL or below CL, a run of 7 or more points are observed, then it is an indication of shift in the process. Whereas according to our chart, a run of 7 or more points above the CL, it indicates variability in the process has been increased. Variability of the process has been increased. Whereas a run of 7 or more points below the central line, below CL, it indicates variability has been reduced. Variability has been reduced. Now come to the 8th point. If the sample points too close to the central line in both the XBar and R charts, this indicates system differences. You don't consider that the process is under control. Too close to the central line means process is under control. If the sample points too close to the central line in mean and range charts, why? They are under control, but why it is indicating system differences? So some kind of differences are observed there because of basically in any kind of production process has some kind of inherent variability may be observed, isn't it? Why? Because handling the mission by one particular operator is quite different from another particular operator. It is a obvious one. It is very, very obvious. Making a particular item by one person, it is obviously quite different from the another particular person. That is the usual thing we all know. That is the one certain thing we all know. There is no kind of discussion on that. No two particular persons produces the item alike, same. No, it is not possible. That is called chance cause of variation. That is called chance cause of variation. So, if you come to the point now, if the sample points too close to the central line in both X bar and R charts, mean and range charts, this indicates system differences within the samples. That is, when considering the samples, we have much differences. And it shows improper selection of samples. Or recording, there is some kind of biases in recording measurements, etc. These are the points we have to see. That is, in SQC, if we are not applying SQC, that is, SQC methods are not applied properly, still specify. That is, in the very first fundamental part of SQC is nothing but collecting the method, collecting the information based on the samples. If you have the system differences within the samples and showing the improper selection of samples and reading the measurements, there are biases in reading the measurements, definitely it is going to be observed properly. Now come to the another point. If the sample points exhibit an increasing or decreasing trend, the sample points exhibit an increasing or decreasing trend within the control limits of control charts, then it indicates gradual shift in the production process. Whatever the sample point continuously increasing trend or decreasing trend is observed in the control charts, then it indicates a gradual shift in the production process which needs resetting of the machine. Continuously increasing or continuously decreasing trend or the pattern is observed in the control charts, then it indicates it needs resetting of the machine. It indicates gradual shift in the production process. Kindly you draw a particular chart and then observe these all the things. Just don't imagine. You please draw the graph continuously between UCL and LCL, whatever the cases I have specified, above the CL, below the CL, a run of 7 or more points, below the CL or above the CL, according to XBar chart, according to R chart. Please draw the diagrams and submit to me. And take a photo, take pics and send it to me. Next, the last one. If the fraction defective control chart, P chart, in the fraction defective control chart, P chart, if some of the sample points fall above UCL, known as high spots, if some of the sample points fall above the UCL, known as high spots, then there is an indication of it is an indication of deterioration in the quality. You see, even though we have certain quality level is going to be accepted according to the control charts, which means all the sample points falls within the control limits UCL and LCL, but even then we have to observe these things. Some particular sample points fall above UCL, high spots, then it's an indication of deterioration in the quality. Quality is going to be deteriorated. Fine. Like that, we have to observe clearly all the interpretations. Interpretation is very important to give a valid conclusion. Valid conclusions are made through these particular interpretations. We have to keep all these points in mind for giving a good or better interpretations. Thank you.